Hello folks, I am Faisal Khatri. In today's video, I'll teach you about the page object model, a powerful design pattern that helps make your test automation cleaner, more maintainable, and easier to scale. What will you learn in this video? We'll learn about what is a page object model or POM. Why do we need a page object model? We'll also learn about the core concepts of the page object model. And finally, we'll learn how to implement page object model using Selenium WebDriver with Java. I'll be implementing the page object model using Selenium WebDriver in Java by step for a test scenario using OWASP Juice Shop website and walk you through the code for better understanding. But before we begin with the implementation, let's first understand the basics and the core about the page object model. So it's better to uh, get the hands-on while implementation and easily understand what the design pattern is and how it helps us in the test automation. What is a page object model? A page object model in automation testing is a design pattern where each page is represented as a class with locators and methods, separating UI from test logic to improve readability, reuse, and maintainability. In web automation testing, the tests interact with the UI and perform different verification steps. A page object represents the page elements as objects in the automation test scripts. This helps avoid duplicate code, and if the UI changes, the changes can be updated at one place. In POM, each page of your software application is represented by a class called a page object class. And this this page object class contains locators. Locators are a way to find an element on a web page, like a button, input field, or link. It tells the test exactly where to click or type. The examples include ID, name, CSS selector, and XPath, and so on. There are a total of 8 different types of locators in Selenium WebDriver. Method or action. A method is a function inside a page object class that performs a user interaction like login, click submit, or enter username. The test call these methods instead of directly interacting with the elements. Test script. The test script is the code that runs a test scenario, like logging into the website or adding an item to the cart. It uses page objects instead of finding elements directly. Why do we need a page object model? POM centralizes, or page object model centralizes page actions, hides UI details, and reduces duplicate code. The page object model offers various advantages that could help make the Selenium test more organized, efficient, and maintainable. Code reusability. Page object model allows us to create reusable methods for page actions in the page object classes. This approach enables the reuse of the same code across multiple tests and improves code reusability. Code maintenance becomes easy. When there is a change in the UI of the application, updating the locators, actions, or tests can be a tedious task. With POM, the locators and interaction methods are included in different page object classes. With this approach, the necessary changes can be made to the respective page object classes, making maintenance easier. Enhances code readability. By creating separate page object classes for each screen, the test logic is kept separate from the locators and interaction methods. This keeps tests clean and focused on validations, improving readability and allowing team members to easily understand the functionality under test without getting confused by the technical details of the web page. Reduces code duplication. With page object model, the web elements and the page actions are centralized in the page object classes. This encourages the dry or do not repeat yourself principle, making tests easier to maintain and less prone to errors. Better test abstraction and encapsulation. In page object model, the details of the UI interactions are hidden inside easy to use methods, allowing test abstraction. This makes the test focus on actions to perform rather than how they are done. The page object classes keep the locators and interaction logic encapsulated, thus shielding the test scripts from complexities of the UI. Core concepts of the page object model. In page object model, an organized approach is followed. built around core components including page classes, locators, and methods. What are page classes? In page object model, a dedicated class is created for every web page. This dedicated class contains all the page objects for the web elements on the page, including buttons, text boxes, checkboxes, links, and other elements. It also has the action methods, which are used for interacting with these web elements on the page. For example, if you are testing the registration page of a web application, the locators related to the respective page will be updated in the registration page class. Similarly, for the login page, a new class, login page, will be created to store these web elements. Similarly, for the login page, a new page class, login page, will be created to store its web elements. Locators. Locators specify the way web elements are identified on a page. Selenium WebDriver offers 8 different locator strategies to locate a web element, including ID, name, CSS selector, XPath, link text, partial link text, class name, and so on. With POM's centralized approach, it's easier to update locators whenever the UI changes. For example, locators can be stored as constant variables within the page classes. So if a locator changes, only the corresponding variable needs to be updated without altering the code test scripts. Alternatively, locators can be maintained in external files such as JSON, YAML, or properties file. But it all depends upon the implementation, how you want to implement the things. It's better to write page object class, or if you think you need a separate external file, it all depends upon how you implement the thing. Methods. Methods in page object model are designed to interact with the web elements and perform the required actions. The automation test can call these methods, enhancing the code readability and reusability. For example, a perform login method can be added to the page object class to simulate a user logging in by entering the email and the password and clicking on the login button. This method can then be directly called in the test, keeping the test script concise and easier to read. Implementing the page object model in Selenium WebDriver. Let's implement the page object model using Selenium WebDriver in Java. We'll implement the following test scenario using the OWASP Juice Shop website, where we will register a new user and log in with the user. But before we begin implementation, let's first analyze the website and check out how many web pages we need to interact with. So let's go through the website and just do a round of manual verification and analyze the website, how easier the scenario would be to navigate, and how many web pages we will be required to create, how many page object classes we will be requiring to create for handling this in the page object model design pattern. I'll be running the OWASP Juice Shop website in my local using Docker Compose. So let me run the Docker Compose command first so that the website is up and running in my local. Okay, so you can see the network has been created and the Docker container for the Juice Shop website has been started. Let me quickly navigate to localhost 3000. Also, let me show you the file for your better understanding. So this is the file that will pull this image for the Juice Shop website from Docker Hub and expose the port 3000. So our website will be started on localhost 3000 port. As soon as we navigate to the localhost 3000, we see a welcome message with a dismiss button and also a cookie pop-up that we need to click on in order to start with the test automation smoothly. So we'll click on this dismiss button. Whatever steps we do here, we'll have to perform the same steps in the test automation also for smooth navigation of the test. So we'll first click on this dismiss button and also click on this me wanted button. Both of these pop-ups appear on the home page. So the first page that we need to handle is the home page, on which we have the account link as well. As soon as we click on this account link, the login link will be displayed. Fine. So once we click on this login link, we will be navigated to the login page. Now on the login page, you have a link for registration that shows not yet a customer. So once you click on this link, you will be taken to the user registration page. Now this is the third page that we will have to work on. and prepare a page object class for before we write the test. Okay, so there are three pages involved in this journey. The first one is the home page, the second is the login page, and the third one is the registration page. Let's go to the implementation part now. So I have created a page object model demo package. Inside that package, I have created three different packages. One for the pages. This pages package will include all the page object classes. Another is for the test data, which will take care of the test data, where I'll generate the test data for registration or maybe new user registration. So this data will be test data will be supplied using the registration data. In the later part, I will explain you how I use this test registration data class. And the third package is the test, which we will use to write the base test. The base test is ideally for setting up and tearing down the configuration part. It's mostly related to the Selenium WebDriver setup and tear down. And then we have the test. So this test class contains all the tests for the user login and the registration of the user. The base page class is created to store the common implementation and page objects. Like you can see the WebDriver, wait, WebDriver, and also we have a snack bar. The snack bar is commonly displayed on the login as well as the registration page. So we have this displayed here. The base page class is created to store the common implementation and page objects. It holds a shared WebDriver instance. You can see this WebDriver. There is a constructor for the base page where we have instantiated the WebDriver and the WebDriver wait as well. So this WebDriver wait is used for handling the explicit wait, and we have the snack bar locator so that we can reuse in multiple page object classes. The constructor, that is the page object, the base page constructor, initializes the driver and a 30-second wait. You can see the 30-second wait that is instantiated, that is used for this WebDriver wait. And there are two methods here: page header text and wait for snack bar to disappear. The page header text method waits for header element to become visible and return its text, whereas the wait for snack bar to disappear method waits until the snack bar notification disappears so we could proceed with the next steps. This method, wait for snack bar to disappear, is created as the snack bar, once visible, does not allow to perform interacting with other elements, and Selenium throws element not interactable exception. Overall, the base page class allows all page object classes to inherit these common utilities and avoid repeating the code. Now let's move to the next page object class, that is the login page class. You can see the login page class is extended by the base page class, so we could use the common fields and methods defined in the base page class. The locators are defined. So these are all of the locators which are defined on the top that will be used in the interaction methods. You can find the interaction methods below, like the user login, open registration page, and so on. The open registration page method will navigate to the registration page and then return a new instance of the registration page class. A new instance of the registration page class is returned as once the user navigates to the registration page, it will load the registration page and the user can perform the registration actions. Likewise, the user login methods takes the email and password as parameters and performs a login action and then returns a new instance of the home page class. The user login method returns a new instance of the home page class because once the user logs into the system, he is taken to the home page. So that is the reason why we are returning a new instance of the home page class. Now let's talk about the registration page class. The registration page class also follows the same pattern. It is extended by the base page class. You can see it's extended by the base page class, and the locators are defined at the start, which will further be used in the interaction methods, that are the new register new user, registration success text, and select security question. This select security question will be used in the register new user method only. The register new user method takes in the registration data from the registration data class. Now let's talk about the registration data class also. So the registration data class uses the data and builder pattern, builder annotations from Lombok, which helps in keeping the class concise and to the point by removing the boilerplate code. Now, why I have defined all of these four fields, you can check this registration page: email, password, repeat password, security question, and answer. So you'll find all of these four fields. Now, ideally, repeat password is not defined here because it's the repeat password. So I can ideally use the password again to fill in for this field value. And there are ideally, if you can see, ignoring or removing the repeat password, there are four fields. That is email, password, security question, and answer. The security question is a drop down which has a list of the questions. So we'll talk about this also in some time. So the registration data has all the fields related from the user registration screen. The registration data builder class takes in the registration data from the registration data class. So you can see this get registration data method returns a set of registration data. The registration data builder class implements the builder pattern in generating the registration data and runtime by using the data faker library. So I'll quickly show you the POM.xml, as it is important here to for you to know how the implementation is going on. So we have different dependencies available in the POM.xml. The first one is the Selenium Java, then test10g, and we also have the project Lombok and data faker. This Lombok is used for that annotation at the rate data and at the rate builder, which we saw in the registration data class. And this, using both of this builder data and the data annotation, we are generating the data at the runtime. So if you see, the registration data builder class returns this builder instance, right, where it will take in the email, it will generate a fake email, maybe using the data faker library. It will generate the password, that is the constant password that I put here. There was a reason of putting this constant password, and I don't want to like generate a new password, and which I won't be able to know, because using the faker class, if I faker class or library, if I use the pass on the password, I will not be able to understand which password was generated. Maybe I'll have to write extra code to fetch the password value. So it's better to put some static value here that can be used in every user. So the password remains constant. Every time this registration data builder class runs, it will generate a new fake email, but the password will remain the same. And also we can generate write a line of code to get the email ID that is being put, right? We can also print this email ID in the console in that using the test. The registration data builder class implements the builder pattern in generating the registration data by using the faker library. You can see some of the data are hard coded, like the password, security question, and security answer. This is just for my own purpose, that I don't want to I want to remember these things, what were the questions and what were the password or the answer, security question and security answer, so that I can make use of them in case I forget the password, and I can be able to reset the password as well using these values. The data is passed. This data, whatever data we generate here using the registration data builder, it will be generated using, once we call this get registration data method. And once you go to this register new method, you'll see the registration data being used here. But this get registration data will be finally used at runtime while running the test. We will not be calling this in the page object class. Fine, we'll just pass on the placeholder values using the registration data class, and once we write the test, we'll use this get registration data. I'll explain you once we come to the test. So you, in the register new user method, the respective values in the fields are filled using the registration data class. Like for example, you can see here the email ID. We first locate the email ID field and then clear that field and send the values from the get email. Whatever runtime data for the email is generated using the data faker library, it will be posted in this email field. Similarly, the password will be posted in the password field, and then a repeat password, also the same password will be sent. And then comes the security question. Now, For filling the data for the security question field, I have defined another method that is a private level that will be used within this class only. And that method name is select security question, which takes in the parameter, a string from the question text. So whatever question text that you want to use, you can ideally pass on using this parameter at runtime. The select security question method is created as it helps in removing the complexity and presents clean code. So you'll see all of this line of code that is necessary for selecting the security questions have been isolated in another or been moved to another method, and we see a clean method while registering the user. We just call the select security question method, and it will fill in the respective values for the security question. All the implementation is written or maybe moved to the another method, that is select security question. The select security question method takes the question text as a parameter at runtime and will compare the question text that is supplied as parameter with all the questions in the security question dropdown. Once the question text matches, it will select the question by clicking on it. So you can see it will first click on the select security question method. Let me show you on the website. So this field will open, and then all of these question set of questions that are displayed in as a list, it will be fetched in this particular variable. So it will get all the elements located by this locator, and then the loop will run where it will iterate through each and every question and compare using the text that is provided. And if that particular text matches the question's text which is supplied, so this question text matches with the question that is present in the particular question field, it will click on it, update the found equal to true and break the loop and come out. In case if you supply any weird text that is not available in the question text in the question field, then it will print this method. It will print this text question not found in the list, and then we'll exit the loop and the registration will not be performed. We have completed all of the page object classes, the page, home page, login page, and registration page. We also worked and talked about like registration data, the data that will be supplied in the test as a test data for registering the user. Let's talk about the base test class. It is used for setting up the common test configuration. You can see it's just a configuration that is being supplied here. And it will be shared across all the test classes. It declares a protected WebDriver so the child classes can access it. The before class annotation is updated here at the above the setup method, so that this method runs every before every test in that class, and it initializes the Chrome driver and then maximizes the browser window. I've not used any implicit wait here, as I have used explicit wait throughout the page object model, which you can see in all of the page object classes. You'll see the WebDriver wait. The base page, it already has the implementation the instantialization of the WebDriver wait. But if you go to the any of the web page object classes, you'll see wait until expected conditions. So I'm just waiting for the visibility of this logout button. I'm waiting for the visibility of this locator before I check the condition or click on it. Similarly, for the login page, if once I'm on the home page, I'll wait for the dismiss button to be visible and then check if it is displayed, then only I'll perform a click. Similarly, for the me wanted button, I'll just check if it is visible, if it is displayed, and then perform a click on it. Then next, for the snack bar, I'll just wait for it to become invisible, that is to disappear, and then I'll perform the next steps to find the and locate the account link and click on it, and then I'll wait for the login link to be clickable and then perform a click on it. Finally, the login page will be returned. Once I go to the login page class, you'll see user login method. Or maybe if I want to open a registration page, then again I'll check. This is all explicit waits. Fine. Using the WebDriver wait, I have used this element to be clickable for the customer, not a customer link, for the registration purpose. So once I click on it, I'll just, before clicking on it, I'll just check if it is clickable or not. If it is not clickable, then a particular exception will be thrown by Selenium, and the test will stop there. It will fail that the stating that the element is not clickable. So this way, I don't need to put any implicit wait. I just wait for the respective field only for the time for the respective condition to be true, and then the test will move on. So it's not necessary to put in any hard weights in the test, and this will save my time and efforts as well during the test execution, and it will be give out more ROI on the test results. Like I'll be saving more time out there once I use the explicit weights. Coming back to the test class, I was talking about the implicit weight. So I've not used any implicit weight. I just explained like how I used explicit weights on every field to save my time and check out the condition before I perform any interaction on any of the fields. The after class method now, that is the teardown method. Uh, it runs after all the tests are finished and calls the driver.quit. You can see the driver.quit, which gracefully quits the WebDriver session and closes the browsers and cleans up the resources. Now, let's quickly jump on to the test. You can see the Juice Shop test class extends the base test. I have defined the registration data, and before I run any of the tests, I have just instantiated this or called this get registration data. Like I said earlier, the registration data builder builds the data and keeps it ready. As soon as this get registration data is called in the test, we have the test data for the registering a new user readily available before any of the test runs, so that as soon as the test executes, we get the data available at runtime, and similarly that data can be passed on while registering the user. And since this Juice Shop test extends the base test, it inherits the WebDriver setup and teardown method from the base test class itself. A registration data object, like I said, it's declared to store and test data, to store the test data for registering, for registration and login. So ideally, whatever data we use for registration, the same data is used for login as well. Ideally, we need the email and password, because password is already hard coded, pass@123. For the email, it will be generated by the Faker library at runtime. That data will get on the by calling this method, get registration data. Now there are two tests. We have two scenarios. The first scenario is test register user, and the second scenario is test user login. So this test register user, it opens the Juice Shop app by navigating to localhost 3000. Like I said, I'm using the Docker Compose to run the run the OWASP Juice Shop website in my local. So I'll call this driver.get and localhost 3000. Ideally, you can supply the link to your actual website here in the get method. Ideally, navigate.to. Sorry, driver.navigate.to. This method can also be called instead of get, but it all depends how you implement. I'm using driver.get to call the or navigate to the website. And next we create a homepage object, and then we create a login page object. You can see the magic here. We have instantiated the home page, but we have not used the login page equal to new login page here, because when we open the login page, it already returns a new login page instance internally while using the homepage class, right? So this open login page returns a new instance of this login page. That is the reason why when we instantiate the login page, we just call the method homepage dot open login page, and this open login page method internally creates a new instance of the login page, which is what it returns. And then just to verify that we are on the correct page before we start with the registration scenario, we just verify that the page header text. Now you can see this here, it is from the base page. This is a generic method which returns a new string for the page header text using the locator that is supplied here. And I have used this page header text from the login page. Now this page header, I've just defined the I have just defined the page header locator here, but the method is called directly from the base page itself. And this locator is updated in the base page in the method parameter. That is what we have here. Like login page dot page header text, I'm just placing this page header. So using this app CSS selector app hyphen login space h1, it will locate for the page header on the login page, and then verify it shows login. For example, if I go back to the login page, you can see this header text it is located on the login page to verify that we have correctly loaded the login page. And once we have this assertion passed, we move to the next step, that is registration. Now again is the same thing that I explained before. In the registration page instantiation, we just call the login page dot open registration page. Now this open registration page, it returns a new instance internally on the by the page object class for the registration page. That is the reason why registration page equal to login page dot open registration page. And once we are on the registration page, we again perform a kind of assertion to check the page header text is correctly displayed as user registration. Now, if I click on this not yet a customer, you see this text user registration, which is what I'm verifying here. Again, this page header text is from the base test class, base page class. Sorry, this is from the base page class, and it's a generic method. If you go to the registration page, you will find the locator here, mat-card h1, which is a CSS selector, and that is what I have updated here, registration page dot page header text. Now you see the reusability part of the page object model here. In the login page, we have defined the login page selector, whereas for the registration page, the method is the same that is defined in the base page, but there are two different locators applied at runtime to the respective methods, and we perform different assertions as well. This is where the page object comes very handy. You don't write duplicate code, you follow the drive principle, and then you it's easier to maintain also. So in case if in future anything changes on the page header text, like if there is any change here, or if it is not working, I just have to do a single change on this page header text in the base page class itself. I don't have to write multiple lines of code for getting this page header text. Though we have a different locators, we can call that those locators at runtime, and accordingly it will be the changes will take place. Next, since this registration page object is already created, we call the register new user. Now, once we call this register new user, we need to supply the registration data. So that is what the parameter says here, right? So this registration data we have already defined before test. This is called the from the registration data builder. It will call this get registration data and supply the respective data using the builder design pattern. If you want to learn more about builder pattern, how to create or generate test data at runtime using builder design pattern, I have a blog in Medium already available. I'll have posted the links to that particular blog as well in the description. You can check out the blog, and it's easy to implement and get your things done. So you can see how easy it is to generate the data at runtime and use it in the test. So we supply the registration data to register the user. After that, we return the registration success text. So this particular method, it waits for that particular text to be available, uses the locator simple snack bar div, which is a CSS selector, and ideally we get the registration text, which is this registration text. Registration completed successfully. You can now log in. So this completes the register new user test. Now, if I talk about the test user login, it's far more easier and concise than the register new user test or registration test. So since we are testing things differently, we again define an object for the login page. And this time I need to define this login page object because there is no method that I have for instantiating or calling up. So I have defined this login page here, and then we will wait for the snack bar to disappear. Now what happens is, once the registration is successful, we see a message at the bottom, a snack bar that shows that registration completed successfully and now you can log in. So we will wait for that snack bar to disappear before we start our login test. That is why we have this wait for snack bar to disappear method here, which will wait for the invisibility of the element. That is, we will wait for that snack bar to disappear, and once that snack bar disappears, we will just check that we are on the login page, right? Because once this register new user method is successful, or the registration is successful, it already moves to the login page. And then we call this user login method, which will take the email and the password as a parameter, locate the email feed, password field, and then type in the values in those fields, and then click on the login button and send a or return a new instance of the home page. Since after login, the user is taken to the home page, so we return a new instance of the home page, right? And once we get to the home page, there is an assertion we need to check that the login is successful or not. So to confirm that, we will just call this logout button displayed method, is logout button displayed method, which returns a boolean. So what we do is we wait for that account link to be visible. After login, we will wait for that account link to be visible, and then perform a click on it. Once we click on it, we will be able to see and locate the logout button there and verify that if that particular logout button is displayed or not. So if this condition is true, then ideally the assert true will be working fine, which means the test works successfully or the user logged in successfully and the test passed. Now, to execute the test, this test.ng file is created, which helps define and organize the how the test should run as a part of structured test.ng test suite. Here's how each of the different parts present. The suite, ideally, this tag defines the test suites and gives it a meaningful name. Like I have defined it as a page object model demo with Juice Shop website. Then we have the test tag. So you see the suite is the higher level tag. Then we have the test tag, which defines the name of the test that we want to put under this suite, and it shows the names as name as registration and login test, since we will be running registration and login test inside this particular test. And then we have the different classes available here. The classes tag, we can put in different classes. So ideally, we need to put in the fully qualified name of the class here. So the Juice Shop test class, the fully qualified name is io.github.mfslk3 page object model demo. This is the package name. Then we have a test package, and inside that package we have the Juice Shop test. After that, there is a tag for methods, inside which we can order or we can put in the name of the methods that we want to execute, the test methods ideally that we want to execute. So the first test that which we want to execute is the test register user, and then the test user login. So this is how you can preserve the order of running the test as well. So in case if you have 10-15 different tests and you want to run the test in a specific order, this is where you can put in the name of the methods that you want to particularly execute. So in case if it is include, then only that particular method will be run while test execution. Otherwise, if it is exclude, it will not run. So now if you want to run the test, there are specific 2-3 steps that we want to make sure that we run as a prerequisite before we execute the test. The first, since I said that we are running the test using the Docker Compose, so we need to make sure our Docker is started. Like we have the Juice Shop available, it's started. The container is started. Let's navigate just to check if it is working fine. Yeah, it's working fine. And then what we need to do is we need to just right click on this and run the test. And just check. It will run the test for us. You can see the snack bar is there. It's waiting for the snack bar to disappear now. And then it performed the test for the login. So ideally the test register user, test user login, both of the tests ran successfully. And you can see the test.ng shows us a report like total 2 tests run, 2 pass, 0 failures. So this is how you can use leverage page object model in your test automation suite for writing cleaner and maintainable test. Just to summarize, the page object model is a functional design pattern that drives effective test automation. It helps in building maintainable, scalable, and robust test automation framework with Selenium. By separating the web elements, actions, and locators in page classes, an abstraction layer is created that keeps test scripts clean and focused on test logic. It reduces the code duplication, improves readability, and makes it easier to update tests when the UI changes. Thank you for watching this video and happy testing. Do like, subscribe to my channel, and share it with your friends.